Capacitors. A capacitor is a component that can store charge. A dielectric is an insulator. How capacitors store charge. Before the battery is connected to the capacitor, there is an equal distribution of positive and negative charges on each plate. When the switch is closed, electrons flow from the negative terminal to the bottom plate, where a negative charge builds up. This repels electrons from the upper plate, which are then attracted to the positive terminal, so a positive charge builds up on this plate. The number of electrons repelled from the positive plate are the same as the number of electrons that build up on the negative plate. This electrostatic repulsion causes a flow of charge across the plate, producing a potential difference and ultimately a uniform electric field. Capacitance. Capacitance is the amount of charge stored per unit potential difference and is given by C equals Q/V, where C equals capacitance, Farads, Q equals charge stored, C, and V equals potential difference, V. The voltage rating of a capacitor is the maximum potential difference that can be safely put across it. A capacitor will only charge up to the potential difference of the battery or power supply it is connected to. Since the capacitance of a capacitor is fixed, charge stored and potential difference are directly proportional. Uses of capacitors. Capacitors can only store small amounts of charge. To store the same energy as an AA battery, a 6000 F capacitor would be needed. They discharge their power very quickly and are commonly used in time-dependent circuits where charging and discharging takes place at regular intervals. Camera flashes. Converting AC to DC. Charging a capacitor. Capacitors can be charged through a fixed resistor. The resistance of the resistor will affect the time it takes to do this. When fully charged, the potential difference across the capacitor will equal the potential difference across the power supply. 1. At the start, current and potential difference are both 0. 2. The switch is closed and current then starts to flow. 3. The potential difference of the battery causes an initially high current to flow. 4. As the capacitor charges, the potential difference across the plates increases. 5. The current will start to decrease because electrostatic repulsion makes it harder for more electrons to be deposited on the plate. 6. When the potential difference across the capacitor is equal to the potential difference across the power supply, the current falls to 0. 7. The capacitor is fully charged.